Welcome back to Part 2 of Chip Component Rework. Let's continue now with a discussion of chip installation methods using a hand soldering iron. We'll be able to use the same installation procedures for almost all of the different types of chip components except for ceramic chip capacitors. The first technique will be to pre-fill one of the lands with flux cord solder. We'll add enough solder on one land to create a slight crown shape. Again, the best way to learn the right amount is through practice. Some companies may require that you clean off the flux residue from the pre-fill operation prior to adding any additional flux. Now we're ready to align the component in the correct position. You'll notice that the pre-filled land will lift the component off the board slightly. Next, we need to add flux to remove any oxidation that will be formed during the resoldering process. Now we'll hold the component in position with a wooden stick or tweezers so that the soldering iron won't push the component out of alignment. When we apply heat to the pre-filled land, the solder will wick up onto the termination and the component will drop down onto the land. After you remove the tip, wait 1 or 2 seconds for the solder to solidify before removing the holding tool. The tip should contact both the land and the termination while the solder is added to the opposite side. Be sure to add enough solder to form a proper fillet. You can use almost any style of tip you prefer for either soldering operation, chisel or conical. Keep in mind that it's best to use the largest tip possible to transfer heat as quickly as you can without damaging the board or any adjacent solder joints. After both sides are soldered and cooled off, the flux residue should be cleaned with the proper solvent to keep it from hardening. Again, there are no clean fluxes that don't require cleaning. Just be sure to comply with your company's cleaning procedures immediately after work on that assembly is completed. You can also use a bifurcated tip to install chip components. In this procedure, we will pre-fill both of the lands with flux cord solder. We'll need to add enough solder until there's a visible crown present on both lands. You'll learn the right amount of solder pre-fill after a few tries. Again, it's always best to remove any used flux residue at this point. Now we can align the component properly on top of the pre-filled lands. Then we need to add new flux to remove any oxidation that will be formed during the reflow process. We'll have to hold the component in position with a tweezers or a wooden stick. Now touch the solder pre-fills with the fork tips. At this point, you should see the solder melt. You should also feel the component drop down onto the lands. After the iron is removed, you'll need to hold the component down for another second or so until solidification is complete. Then remember to follow up with the recommended cleaning procedures required by your company. There's also another way to secure a chip component without having to physically hold it down. We can place a drop of adhesive between the lands and then align the component on top. Now we'll push the component down until it sits flush onto the lands. You need to be careful to keep the adhesive off the lands. If you add too much, the downward pressure of the component can cause the adhesive to squeeze onto the lands. Adhesive that bleeds onto the lands will get in the way of a good solder connection. The proper amount of adhesive needs to be applied directly in the center between the two lands. After you position the component, you'll need to cure the adhesive according to the manufacturer's specifications. We'll be using flux cord solder and the largest tip you can safely use without damaging the board or any adjacent solder joints. The size of the solder wire is also important when soldering small components. If the solder is too thick, it's easy to melt too much solder into the joint. If the solder is too thin, it can take too long to melt the right amount into the joint. In this case, you would have to leave the heat applied longer, which can cause thermal damage to the board. This covers all of the recommended replacement procedures for hand soldering chip components. Let's stop to review any questions you have on these specific installation procedures. In this next section, we're going to cover the removal of chip components using a pulse-heated tweezers. Let's begin with the removal process. The amount of pulsed electrical energy or heat will need to be adjusted to the job at hand. The tool manufacturer or your company's standard operating procedures should have a reference manual that lists specific heat settings for chip components. Adjust the dial on the heat source to match the recommended setting for chip components. Now add flux to both sides of the component that we're going to remove in order to enhance the heat transfer process. If the tips touch another component or solder joint as they are being positioned, they won't cause any damage since they aren't hot yet. This can be a real advantage on high-density assemblies. After the heat switch is activated, the tips will take a few seconds to heat up and melt the solder joints. When you're sure that all of the solder is molten, lift the component straight up and turn off the heat. The hot component should be placed on a wet sponge to cool to avoid burning your work surface. That covers the chip removal process using a pulse-heated tweezers. Now let's talk about component replacement. Because of the relatively slow heating of the pulse-heated tweezers, you have the advantage of using either solder wire or solder paste for component replacement. Let's begin with the solid solder pre-fill technique. Assuming that you have prepared the lands after component removal, we'll use a soldering iron to melt a properly sized crown of solder onto both of the lands. The relative size of the component terminations will affect the amount of solder in the pre-fill. For example, a MELF component has more metal surface area on the termination than a chip resistor. This means that it will require more solder in the pre-fill to create an acceptable fillet. After both lands are properly pre-filled and cleaned, we need to add new flux. We'll be using the same tip sizes and heat setting from the previous removal operation. Grip the component terminations with a light touch. Then position the component exactly where you want it. After the heat is activated, it should take a few seconds for the solder pre-fills to melt. You should feel the component drop slightly as the solder melts. Then release both the thumb and the finger simultaneously. Then deactivate the power. If one side of the tweezers is released first, the spring action of the tool can push on the component and knock it out of position. You may want to hold the component with a non-damaging tool to avoid problems in releasing the tips unevenly. If you decide to use a holding tool, you will lose the advantage of the self-aligning tendency of the chip component. This means you must make sure that the chip is accurately aligned during the soldering process. Whenever you use a tool to hold a component in position, it's extremely important to keep it perfectly still during solder solidification. If the component moves even a slight amount during the hardening process, look what happens to the structure of the solder. This type of grainy texture is not just a cosmetic problem, it indicates the structure of the solder is disturbed and likely to fail. Another technique for installing chip components with a pulse-heated tweezers uses solder paste. Assuming that the lands have been properly prepared after component removal, we're now ready to dispense solder paste onto both of the lands. There are a number of different ways to apply solder paste, ranging from manual dispensers to regulated air pressure units. You'll need to get experience with the dispensing tool that your company provides. The amount of solder paste will also vary depending on the size of the lands and the style of the terminations. Again, larger terminations will require more solder to obtain the correct fillet size. After the solder paste is applied, you're ready to install the component. Pick up the component with the tweezer tips, grasping it about halfway up the termination. Now we align the component while the tips are still cold. Don't press the component down onto the lands. Just place it lightly into the solder paste and then activate the heat. After you're sure that both joints are molten, release both sides of the tweezers at the same time. The surface tension of the solder should center the component on the lands. Now the heat can be turned off. After cooling, the flux residue around the joint can be cleaned up. Let's stop and review any questions you have on pulse-heated tweezers. In this next section, we're going to discuss chip component removal and replacement using continuously heated thermal tweezers. This tool was originally designed for component removal, although some people use it for installation as well. We'll explain both operations, beginning with component removal. As a starting point, you should set the tip temperature to 316 degrees C. As your skills improve, you will learn to vary the temperature according to the requirements of the job. The continuously heated tweezers have an adjustment screw located at the back of the tool. You might want to set this screw so the tips will open around half a centimeter wider than the width of the component. In some cases, there may not be that much working space around the component. You may have to adjust the spacing of the tips to allow for this condition. There are a much larger variety of tips available for this tool compared to the pulse heat tweezers, including an angled version for chip removal. The angled tips allow you to come in from the side. This makes it possible to work under a microscope to get a better view of what you're doing. For chip components, you'll want to size the width of the tips slightly smaller than the width of the land. We'll begin by fluxing both sides of the component. Then we contact the terminations lightly, without touching any other components or solder joints. In 1 or 2 seconds, you should see the solder melt. After you're sure that both joints are molten, lift the component straight up. Now let's talk about removing chip components that have been adhered to the board. We'll be using the same procedures as before, except that we will continue to apply heat after the solder melts for a few additional seconds. This additional heat will travel through the component and soften the adhesive. At this point, you can start to apply a gentle twisting motion to make sure the adhesive has been loosened. Now lift the tool upward and remove the component. Some adhesives will tend to loosen faster than others, depending on the size and shape of the component and the type and amount of adhesive. Now you can prepare the lands for component replacement. It's also possible to replace a chip component with continuously heated tweezers, although it takes a skilled and steady hand to achieve acceptable results. Let's take a break here to discuss removal of chip components using continuously heated thermal tweezers. In this section, we're going to review the chip removal and replacement operations using a hot air pencil. Let's begin by setting the temperature of the air to 427 degrees C. This may seem hot, but keep in mind that the exit air is always much cooler than the set temperature. Think of this tool like a home heating furnace, where the gas burns inside at around 300 degrees C. The hot air that comes out of the vent will only be slightly over 50 degrees C. The hollow tips that you select will also affect the heat output. There are at least 3 different styles of tips available for hot air pencils. The small diameter tips will focus the heat in a small area. The dual tips can heat both sides of a component at once. The flat end tip will heat up a much larger area. Tip selection will depend on your personal preference and on the density or tightness of the components. Once you have selected the appropriate tip for the job, it's time to adjust the air pressure to match the diameter of the tip. To do this, we place a tissue or cleaning cloth about ½ centimeter away from the tip. Now turn up the air pressure until it begins to scorch. This should be reasonably close to the correct air pressure for that particular tip. Additional adjustments can be made as required. Now we should be ready to remove a chip component. If there are other components packed tightly against the one you need to remove, it may be wise to select another tool. Heating adjacent solder joints should always be avoided from a reliability standpoint. Let's remove this chip using a small diameter tip. We've already adjusted our temperature and pressure. Now we'll add flux to aid in the heat transfer and to make the solder shiny when it melts. We'll come in from the side and turn on the air when the tip is about 1 centimeter away. Move the tip back and forth to heat both solder joints at the same time. Both joints should melt within a few seconds if the temperature and pressure are properly adjusted. If the solder doesn't melt within 10 seconds, something is wrong. You'll need to stop and examine the situation. It may be a large conductor or ground plane connected to one of the lands. This will require additional heat to be focused on that side. Thick, multi-layer boards will also absorb some of the heat and slow down the process. Let's try again now with a melt component. Once again, we'll use a single curved tip and move the heat back and forth to melt both joints simultaneously. When both of the solder joints are molten, carefully reach in with the tweezers or vacuum tool and pick up the component right in the center. There are a few important things to keep in mind. The first being that you have to be sure that both joints are completely melted before you attempt to remove the component with the tweezers. If you try to remove the component too soon, the lands or the component can be damaged. If the air pressure is too high, the component and the solder can be blown right off the lands. This can create additional rework. Too much pressure can also reflow adjacent solder joints. Even if they don't get quite hot enough to melt, the solder can become brittle from excessive reheating. If the pressure is too low, it may take too long to melt the solder, or it may not melt at all. In either case, excessively long heating could affect nearby solder joints or the internal structure of the board. You'll need to practice with each of the different tips to see which one you prefer for different situations. Now let's talk about component replacement using the hot air pencil. First, we prepare the lands using a vacuum extractor or solder removal braid. It's a good idea to clean any used flux residue before we apply solder paste onto the lands. Once again, the correct amount of solder paste will depend on the size of the lands and the component termination style. Pick up the component with the tweezers and place it lightly into the solder paste in the center of the lands. If it's off slightly, that's okay, since it should center itself when the solder melts. Assuming that you have adjusted the power supply for the correct temperature and air pressure, this time we'll want the tip to be positioned directly on top of the chip, about 2 centimeters away. The extra distance will allow us to pre-dry the solder paste slowly. This will allow the solvents to evaporate rather than explode. If the tip is not positioned directly on top of the component, it could blow the component sideways when the solder melts. When the top of the solder begins to liquefy, move the tip down to approximately 1 centimeter away from the component to completely melt all of the solder. It's a good idea to keep the heat applied for one more second after all of the solder appears to be melted, to ensure proper joint formation. The surface tension of the solder should automatically center the component between the lands. After the flux residue from the solder paste is cleaned up, the installation is complete. Now let's examine the second installation technique using the hot air pencil. Once the old solder is removed, we can pre-fill both of the lands using flux cord solder and a hand soldering iron. Again, the height of the solder crown will depend on the size of the lands and the termination style. Now we'll clean the used flux residue. Then we'll position the component on top of the pre-filled lands with the tweezers. This can be difficult with melt components because of their tendency to roll off the solder crowns. You may want to hold the component in place with a toothpick or tweezers. Now we apply flux onto both ends of the component terminations and the solder pre-fills. Assuming you have adjusted the air temperature and pressure according to the tip you've selected, position the tip directly above the component. We don't need to preheat this type of solder, so the position of the tip can start about 1 centimeter away from the top of the component. If you use a light touch to hold the component in position, you will feel the component drop as the solder melts. Now you can remove the tool and allow the surface tension of the solder to align the component. Again, you need to be sure that all of the solder in both connections has melted before removing the hot air. 1 additional second is good insurance. Now the flux residue can be cleaned and the installation is complete. Before we finish, let's talk about the special heating requirements for ceramic chip capacitors. As we mentioned before, due to the structure of the alternating layers of ceramic and metal, these particular components need to be heated gradually to avoid internal cracking. Some manufacturers recommend preheating at a rate of about 2 degrees Celsius per second until the component is within 100 degrees C of the reflow temperature. Place the capacitor on the hot plate, then set the control to the desired temperature and turn on the heat. Some hot plates will sound an audible alarm when the component reaches the temperature setting. Others require a temperature probe to determine how hot the component is. Or you can just wait a few minutes until the component is preheated. You'll want to have the lands already cleaned and pre-filled with solder. In this case, the flux should already be applied before the component is placed on the pre-filled lands, so that you're ready to solder as soon as the component is positioned. The soldering process for ceramic chip capacitors is exactly the same as any other chip component. As long as you preheat the component slowly, you can choose the soldering method you prefer. There are many different ways to remove and replace chip components using the basic principles outlined in this video. Understanding and applying these techniques and a sufficient amount of practice will make your job easier and improve the long-term reliability of your company's products.